Hello, pre-cal students. Hope everybody is having an absolutely amazing day today. We're going to be talking about a subject today that you're actually going to see again if you take calculus. We refer to it as a couple of different things, though, but the main word you could call it is optimization. For example, you want to get the most of a product with the least amount of money. Or you want to get the most area with the most area of a barnyard with the least amount of fencing. So stuff like that. Or you want to use the least amount of fencing. If you want to use the least amount of fencing, it's not necessarily going to be a maximum area. So today we're going to be talking about quadratic applications, which talking about area specifically. And we're going to talk about maximizing, minimizing area. So, Farmer Twiner wishes to construct a rectangular chicken pen. Oh, look, here it is. Using the barn for one of his sides. The other 3 sides will be constructed out of 80 meters of chicken wire. He can make his pen in a variety of shapes, long and thin, short and fat, square, or any shape in between. We want to determine which rectangular shape will give him the maximum. So we want to know what shape would he have to make this chicken pen in order to give him the maximum area if his barn is circular. If you can understand park, I want you to pick one side and give it a variable. Because obviously we don't know how big this one is, right? And we don't know how big this one is, but we know they're the same size because it's got to be a rectangle. There's going to be no fence over here, so if I take my 80 meters of chicken wire and I have these 2 sides, if I subtract what I use for these 2 sides, then that'll give me what's left over for this one, right? Kind of makes sense. So my width over here, I'm going to call that x. I'm going to call this one x over here too, since they're the same. And then for my length, I'm going to take my 80 meters of chicken wire and I'm going to subtract 2x. There we go. So now what this is going to allow me to do is give a variable for my length and width that both involve using the same variable, x in this case. My length is a relationship of how big my x is. If my x's are larger, obviously that's going to take away from my 80 meters, so that's going to make my length a little bit smaller here. Alright, so there's a couple of ways to do this. You know that area is length times width, right? You know that area is length times width. So, area is a function of x. This is just proper formatting. Length is 80 minus 2x, and my width is x. Alright? Now, what this is actually going to tell me a lot of information right here. I can look at just this problem, and I can come up with roots right now. If you set that function to 0, so you'll have 0 equals 80 minus 2x, and 0 equals x, you can actually come up with 2 of the roots. Subtract your 80 over, divide by 2, you get x is 40. So at 0 and at 40, I'm going to have it crossing the x-axis. Alright, so let's see how big this thing is going to get, because it may be a lot bigger than I'm thinking. I'm not sure. Let me get rid of all this. My formula was parentheses 80 minus 2x parentheses times x. And I'm going to go to zoom 6, my standard window. Okay, I can see it popped up right here and here, which means it's going to be really steep. And I don't see it coming back down, so let's make my window, my window's got to go out to 40. Well, that kind of makes sense that I don't see it then, doesn't it? So my x max is 40. You know what? Let's make it 50. Oops. 10. Let's make that 50 just so I can see it. Y max, who knows? We're talking about square feet. Let's say 500. Ooh, need a little bit bigger than that. All right, so let's say 1,000. There we go. And let's find that maximum here. Second trace, 4 for maximum, left bound, right bound, enter. And it looks like it happens at 20.000001, comma 800. So we can probably call that an even 20, I would reckon to say. So at 20, I have a maximum value of 800. Something like this. So my domain is 0 to 40, touching both of them. My range is 0 to 800. What's the maximum area that can be enclosed? Now let's talk about this graph here. What are the x values representing? What is it that the x values are representing in this area, or in this graph? From my formula, I know that x up here is my width. So this down here is your width. But what does this 800 represent? Length times width. If you plug in a 20 for x, right? So 80 minus 2 times 20 is 40. 80 minus 40 times 20, 800. You end up with your area. So this over here is my area. Now that's important, obviously, for answering my questions here. My question says, what is the maximum area that can be enclosed? Well, we found it right here at the point 20, comma 800. So that would be 800, and we're in meters here, so that'd be meters squared. Because it did give me a unit, I want to make sure and use it. And what are the dimensions that would yield the maximum area? Well, this goes back to width is just x, which in my problem, the maximum area happened when my x was 20. My length was 80 minus 2x, which is 80 minus 2 times 20 is 40, so 80 minus 40, 40. And these are both meters, so we've got 20 meters by 40 meters. And that's going to give me my maximum area. So what are the dimensions that will yield the maximum area? 20 meters by 40 meters. Pretty important if you want to, coop up a bunch of chickens. Actually, I did do this one time. I was actually raised on a ranch. My dad let me, I guess was the word for it. It was right about the time that I was, I'd already graduated high school. I was in college. Yeah, I was in college. And we maximized the area of a chicken pen. We didn't use a barn for one of the sides, but that would have been smart. We just made a chicken pen and maximized the area. Funny thing about maximizing the area if you don't use a barn, number 2, this is what I actually did. And I made a pretty important discovery when I did it. So suppose that Farmer Twiner decided to place the pen away from the barn where he would have to build all 4 sides. If he still only has 80 meters of chicken wire, how big can he make the pen? All right, so let's draw a picture here. You're having to build all 4 sides, right? So you've got your width is x. Again, it's going to be x. Now, the only difference here is that if you have your perimeter, it's going to be 2 of these widths plus 2 of these lengths, right? Let's write this down so we can kind of figure this out. We've got 2 of the widths plus 2 of the lengths has got to give me 80. So let's figure out what my length has to be then. I know this plus this plus this plus this has to give me 80. So let's figure out what one of these lengths is. Subtract your 2x, 2l, negative 2x plus 80, and then divide by 2, negative x plus 40. So my length is negative x plus 40 and negative x plus 40. Now my function is still going to be length times width. So my area with respect to x is length, negative x plus 40, times my width. And again, if I set both of those to 0, I can come up with zeros here of x equals, what would that be, minus 40 divided by negative 1, 40 and 0. So 0 and 40. Same zeros again. That's convenient. All right. If the video skipped around a little bit there, I'm sorry. I just noticed my computer was lagging behind a little bit. All right. So we've got parentheses, negative x plus 40. And if you did 40 minus x, it'd give you the same thing, times x. Okay, so it's a little bit shorter than my original one. Notice I didn't change my window. I wanted to compare it to my original one. So my original one was up here. So I'm not going to change my window. I'm going to leave it as is. And then let's find the maximum. Second trace 4. Go a little bit left, a little bit right. At 19 point, no, that's pretty close to 20, so we'll say 20. At 20 comma 400. 20 and 400. Roughly. Ooh, that's a bad looking parabola. All right. So my domain then in this case would be 0 to 40. My range would be 0 to 400. A little bit shorter now. So the maximum area that you can enclose would be 400 square meters. And what are the dimensions that will yield the maximum area? Well, that's going to be my width, which is x, which happens to be 20, and my length, which is negative x plus 40, which happens to be, hey, look at that. If you plug in 20 for x, you get 20. 20 meters and 20 meters. And that's the time that I discovered that if you want to maximize a rectangular area, it doesn't matter what the size of the area is, but if you want to maximize a rectangular area and you have to build all 4 sides of it, then the maximum shape is a square. And I learned that building a chicken coop. Actually building a chicken coop. Funny what you can learn by ranching, isn't it?